Welcome back. In this section, we're going to be talking about rational expressions, which basically means things that look like fractions, things that have a numerator and a denominator. And typically, when we're talking about those, we're talking about things where the numerator and the denominator, or both, happen to be polynomials. A lot of the things that we'll say about rational expressions are similar to things that you would have said about fractions back in the day. Number one, for a fraction to be in simplest terms, there needs to be nothing that could be divided out of both the numerator and the denominator. So, for example, 3/5 is in simplest terms because the only numbers that go into 3 and 5 are 1 and -1, whereas something like 3/6 is not in simplest terms because you could divide top and bottom by 3 and get something that's in simpler terms. The same thing is true for when we're talking about a rational expression. For it to be in simplest terms, there needs to be nothing in common between the numerator and the denominator, no common factors, other than, of course, 1 and -1, because everybody has -1 and +1 as factors. And of course, that means that if you're thinking about a rational expression where the top or the bottom or both are polynomials, to be able to tell if it's in simplest terms, you'll need to factor first. Because, of course, to know if anything has factors in common, you'll need to know what those factors are. So if I'm taking a look at this rational expression that we have, x squared minus 9x plus 20 over x squared minus 16, I can see that both the numerator and the denominator factor out. The denominator factors nicely as x minus 4x plus 4. It's a nice little difference of squares. And for the numerator, looking for numbers that multiply to positive 20 and add up to -9, that's -4 and -5. So x minus 4, x minus 5. That would be my way to factor the top. And I noticed that for the x minus 4, that it's a common factor for both the top and the bottom. So in simplest terms, I could say that this is really x minus 5 over x plus 4. And notice now, in the numerator, the only thing that could be factored out of the numerator is just a 1. And same thing with the denominator. There are no factors that are in common to both top and bottom other than 1 or -1. So that is in simplest terms. To manipulate rational expressions, basically the rules that we had for fractions are the same rules that we would have for rational expressions. So that means that if you're adding two rational expressions or subtracting them, you'll need to make common denominators. If you're multiplying two rational expressions, you multiply the numerators together, then multiply the denominators together. All of our usual fraction rules still apply. Of course, for things like making common denominators, it's going to be a lot easier to do if you've already factored things. So that's always my first step here. Before I do my operations, I'm going to first factor. First one, the denominator is a nice little difference of squares, so that factors as x minus 3, x plus 3. And the second term, we're looking for numbers that multiply to 3 and add up to -4. That's -3 and -1. So x minus 3, x minus 1. And now I just want to make common denominators. And I can see that both of these fractions already have an x minus 3 in them. The first one has an x plus 3 in the denominator. The next one needs it. So this term I'm going to multiply top and bottom by x plus 3. This has an x minus 1 that the other one needs, so this expression I'll multiply top and bottom by x minus 1. So what I'll have now will be multiplying top and bottom by x minus 1, multiplying top and bottom by x plus 3, and now we have a common denominator, so we can make this just one big fraction. One thing that I will say, of course, is that we're going to need to, once we've combined those numerators together, we're going to need to simplify further, factor again. So one thing I'll do here is just to say that if you were to multiply out the first numerator, that this first numerator, if you were to expand it, that expands to give you x squared minus 3x plus 2. And that for the second term, if you were to expand that out, that gives me 3x plus 9. So you'll notice here one thing that I've done, and this is something to be aware of going forward, is that brackets are your friend. Make friends with brackets. They save us from making little mistakes that can send things off in a terrible direction. Since I'm subtracting these two expressions, subtracting the second one from the first one, I want to make sure that I subtract this entire numerator, which means that I want to make sure that I put that numerator in brackets. If I didn't have these brackets here, if I just had minus 3x plus 9, I'd only be subtracting the 3x. I wouldn't also be subtracting the 9. That's what I need to do. So I'm going to do that. And then lastly, I'm going to just simplify this. And for the numerator, we now have, if I were to write this out, we would have x squared minus 6x plus 2 minus 9, which is negative 7, over x minus 3, x plus 3, x minus 1. Now you might feel tempted to stop right there and say, oh great, we've got an answer, we'll feel happy about that. But remember that we want to make sure that our answer is in simplest terms, and we don't know if it's in simplest terms because we haven't factored the numerator out, and it's possible that maybe there might be something that cancels. So what we're going to do next is that we're going to factor out our numerator. And if we're taking a look at that numerator, things that multiply to negative 7 and add up to negative 6, that would be negative 7 and positive 1. So I would say that for the numerator, that factors as x minus 7, x plus 1. And the denominator, we had x minus 3, x plus 3, and x minus 1. Now at this point I can feel confident because now that I've got my numerator and denominator both factored, I can see that there are no factors in common for both top and bottom, that in fact this is as simplified as it's going to get, so that would be my final answer. Now one thing to note here in the question, I say it but I want to just sort of mention it in words again, is I ask you to leave your answer in factored form, and that's for two reasons. Number one, you need to have your answer in factored form to be able to tell if it's in simplest terms or not. But also, remember that what we're doing right now is maybe going to be the first step of a lot of other things. You might have an equation that you need to solve where before you actually get to the solving, you'll need to manipulate some rational expressions. And for a lot of things that we'll need to do, it will always be easier to do them when things are already factored. So if you've already factored things, don't undo all of your work. So you might feel tempted to multiply everything out. Resist that urge. That's just doing extra busy work that actually is not accomplishing anything important for you. So here, this is the preferred way for us to leave it in nice factored form. Of course, the other thing that's also true is that our order of operations still applies, as always. So if you're remembering our old friend BEDMAS, brackets, exponents, division, multiplication, addition, subtraction, that the order of our operations is the same as before. So if we're looking at what we have here, you'll say, okay, we have some addition happening, but we also have multiplication happening. So this multiplication, that will need to happen first before I do this addition. That means, of course, that I'm not going to bother making common denominators yet until I've actually done my multiplication. So that x over x minus 3, I'll just leave that off to the side for now. For the other two terms, I will still factor, because of course factoring will make things easier when we are multiplying. And the reason it'll make things easier when we're multiplying is that we'll be able to see what could be canceled from numerators and denominators. So if I'm looking at this now that I've factored that denominator, x squared plus 6x plus 9, that's a nice perfect square, x plus 3 times x plus 3. And I can see that when I'm multiplying these together, that I could cancel an x plus 3 from the denominator with this x plus 3 that's in the numerator. So that's what I'll do before I multiply things together. I'll cancel those out so that what I'll have would be in the numerator just x minus 1, and in the denominator I'd have an x plus 3 and an x minus 3. And now I just need to make common denominators, do my addition, and then I'm pretty much finished. Both of these terms have x minus 3's in the denominator. This one has an x plus 3 that the other one does not. So that first rational expression, I'll multiply top and bottom by x plus 3. And now if I were to just multiply things out, x times x plus 3, multiplying that numerator, that gives me x squared plus 3x. The second numerator is x minus 1. And they can all be put over the common denominator that we have of x plus 3 times x minus 3. So far, so good. So now the only thing that's left for me to do is just to simplify that a little bit further. That numerator, of course, I can combine my terms together. That gives me x squared plus 4x minus 1. And then the last thing that I would have to ask myself is whether or not I can factor out the numerator, and if so, are there any common factors between the numerator and the denominator? Here, the numerator doesn't factor any further. If I were looking to factor this, I would have to find numbers that multiply to -1, which add up to +4. There are no integers that do that. So as far as factoring this with integer coefficients, I can't. In fact, this would be a prime polynomial. So that means that we have simplified as much as we can. That means that the x minus 3 and the x plus 3 in the denominator can't cancel out with anything in the numerator. This is in simplest terms, so therefore we're finished. For the last one that we have here, we have one polynomial divided by, one rational expression divided by another rational expression. We have one thing divided by another. One thing that we'll need to remember, of course, from fractions, if you were dividing fractions, 3/4 divided by, let's say, a half, you would turn that into a multiplication problem, 3/4 multiplied by 2/1. We're going to do the same sort of thing here, the same idea that if we have one rational expression, one fraction divided by another, that would be the same as the first fraction multiplied by the reciprocal of that second fraction. So we've taken our division problem and we've rewritten it as a multiplication problem. And only thing really to do at this point is just to factor. And of course, cancel things out where appropriate. X plus 1's could cancel. The x minus 2's could cancel, which leaves me with just in the numerator x minus 1, and in the denominator just x minus 3. So what we did in the last example there, that was an example of what's called a complex fraction. A complex fraction or a complex rational expression, that's a fraction within a fraction. You've got rational expressions inside of the numerator of a rational expression, or a rational expression inside the denominator of a rational expression. The idea to simplify one of these complex fractions is to first reduce it back to being just a regular rational expression, not complex, and then simplify from there. Now, there's a couple of ways that you can tackle this. And I'm going to do this example that we're going to look at in two different ways. One way that you could do it would be to try to make, for example, in the denominator, a common denominator between these two terms, to combine it together so that we have just one fraction over one other fraction. And then essentially we'd be doing the same thing that we did in the previous problem, turning it into a multiplication problem. So if we wanted to, one way that we could tackle it would be to do this. I could say that we have 1 plus a fraction, and 1 could be rewritten as x squared minus 1 over x squared minus 1. So that I've now got two fractions in the denominator, and they both have the same denominator of x squared minus 1, so I could combine those two fractions together to give me x squared plus 2x. The minus 1 and the plus 1 would all cancel. And at that point, we would have one fraction over another fraction. I could do the same thing that I did in the last example, which is to take the first fraction and multiply it by the reciprocal of the second fraction. And then I would just have to do the same sort of thing that I did in that last example. Factor things out, cancel where appropriate, and then simplify. Now, the other way, which I think is maybe the more efficient way for us to do this, is this. Number one, we'd be factoring things out anyway, so why don't we start off with first factoring out that little denominator that I've got in the bottom. And so the idea for this is that we're going to look at all of our fractions that we have, and here there are only really two fractions, this one and this one, and we'll ask ourselves what would be the common denominator for those fractions. And whatever that common denominator is, we're going to multiply all terms, top and bottom, by that common denominator. So if you're taking a look at this, the denominator that's in common for, or the common denominator that we would have for those two fractions would be x minus 1, x plus 1. If you were making a common denominator, the common denominator would be x minus 1, x plus 1. And so that's what I'm going to multiply everybody top and bottom by. When I multiply the numerator, when I multiply this fraction by x minus 1, x plus 1, the x minus 1's would cancel, leaving just the x plus 1 behind. 1 times this, well, in that case, nothing would cancel. You'd be left with x minus 1, x plus 1. And for the second fraction, when you multiply it by x minus 1, x plus 1, the x minus 1's and the x plus 1's would all cancel, leaving you just with the numerator, leaving you just with the 2x plus 1. So notice that this is actually a little bit faster. By finding that common denominator and multiplying top and bottom by that common denominator, I have essentially taken it from being a complex rational expression and just turned it into a regular old rational expression. Much easier, much nicer. Now, just to clean things off, in the numerator, I'm going to leave it factored because remember, our goal is to leave things in factored form when we're done with them. But the denominator, I'm going to have to expand that, combine it with these terms, factor if possible. So I'm just going to clean things up here and say that in the denominator, this multiplies out to give us x squared minus 1. And that the minus 1 and the plus 1, that those would cancel each other out. What I should be left with, if I were to expand the denominator and then simplify things out, I should just be left with x squared plus 2x. And of course I could take a common factor of x out of the bottom. And that the x's would cancel, leaving me with just x plus 1 over x plus 2. And there we go. That's my answer for what is that expression simplified, and that's in simplest terms.